We are on page 5 and we're going to work out a couple of examples with the equation we have just learned, V equals F lambda. To help us out a bit, I've written the equation in the triangle form. Number 1. Find the wavelength in water of a sound wave of frequency 700 Hz. If the velocity of sound in water is 1.4 kilometers per second. First of all, we have to convert that 1.4 kilometers into its SI unit. As we know, kilometers are not the SI unit, so we have to change them into meters, and we do this by multiplying by 1000. So that will become 1400 meters per second. We were asked to find the wavelength, and we've been given the frequency and the velocity. So if we were to cover the wavelength, we are left with V divided by F. So we'll start off from the equation, V equals F lambda. We can change that into lambda equals V divided by F, placing in the values 1400 divided by 700, which will give us a final answer of 2 meters. So the wavelength in water of this sound wave is 2 meters. Moving on to the next one. Calculate the frequency of a radio wave of length 150 meters, given that the velocity of this wave is 3 times 10 to the power of 8 meters per second. Now this time we have been asked for the frequency. So starting off from the equation, V equals F lambda, if I wanted to find the frequency, I would have to cover F, and I am left with V divided by lambda. Once we plug in the values, we get 3 times 10 to the power of 8 divided by 150. Let me remind you, the symbol here is something that you do not need to write. We only write it because in straight line text on a computer, it is difficult to write it as a raised power like we have over here. But this, and this mean the same thing. You do not have to write it, because I've noticed in a couple of homeworks, some of you are actually copying this symbol down. You do not have to. Alright, so 3 times 10 to the power of 8 divided by 150. That will give us an answer of 2 million hertz, but there are too many zeros there. We have to shorten it and write it in standard form, which will turn it into 2 times 10 to the power of 6 hertz. If you really wanted to show off, you could also write it as 2 megahertz. However, writing it in standard form will be enough. So question 3. Light travels at 3 times 10 to the power of 8 meters per second in air. A bit of a side note, we will be talking about this later on, but you can notice that the velocity of radio waves is 3 times 10 to the power of 8, and the velocity of light in air is also 3 times 10 to the power of 8. That is not a coincidence. We will be discussing this later on, so keep it in mind. So back to our question. Light travels at 3 times 10 to the power of 8 meters per second in air. Question A. What is the wavelength of the 80 MHz waves used for broadcasting on VHF? VHF stands for very high frequency, and it is used in boats and ships, etc. We will talk about this later on. So if we want to find the wavelength, and we've been given the frequency and the speed, then we have to get lambda subject of the formula. So let's start off with the full formula first. So V equals F lambda. To get the wavelength subject of the formula, we are left with lambda equals V divided by F. Now before we plug in the values, there is this 80 MHz, which I suggest to turn it into its standard form, which will be 8 times 10 to the power of 7 Hz. Now plugging in these values into the equation, we will get 3 times 10 to the power of 8 divided by 8 times 10 to the power of 7, which will give us the answer of 3.75 meters. So the wavelength of an 80 MHz wave is 3.75 meters. Last question. What is the frequency of the 1500 meter radio waves in the long wave band? As usual, we have to start from the equation, V equals F lambda. This time we've been asked to find the frequency. So we have to get F, subject of the formula, meaning we will be left with V divided by lambda. This time there are no values to change, so we can simply plug the values in. V, the velocity, is 3 times 10 to the power of 8, it is still the same, and the wavelength has been given as 1500 meters. So F is equal to 3 times 10 to the power of 8 divided by 1500, which will give us 200,000 Hertz, but once again, there are too many zeros there, let's shorten it to standard form, which will give us 2 times 10 to the power of 5 Hertz.